everyone. My name is Fidrioza Althaf Ferdinand and I'm from Mechanical Engineering Department from Diponegoro University, and here I am about to present you about manganese, which is an element used in manganese steel, and as a task, and here I am. Manganese steel. Manganese steel is an alloy steel containing an average of around 13% of manganese. In some cases, even greater than 50% of manganese. Manganese steel is known for its high impact strength and resistance to abrasion once it is work hardened state. Because of its self-hardening properties, manganese steel has been used in the mining industry for many years. Cement mixer, rock crusher, crawler tread for tractors, elevator, and shovel buckets. Also in the vault industry and other high impact environment. Manganese steel has fair yield strength but very high tensile strength, typically anywhere between 350 and 900 megapascals, which rises rapidly as it work hardens. Unlike other forms of steel, when stretched to the breaking point, the material does not neck down. Instead, the material necks and work hardens, increasing the tensile strength to a very high level, sometimes as high as 2000 megapascal. Here are the examples of manganese steel used in the mining industry and the vault industries. So, what makes manganese steel different? As you can see, uh, it's austenitic alloy because it contains average of 13% of manganese steel, which is high, and in some cases exceed 50% of manganese steel, which is very high. What actually is manganese? Manganese is a chemical element with the symbol Mn and atomic number 25. It is not found as a free element in the nature, and it is often found in minerals in combination with iron. Historically, manganese is named for pyrolusite, known as manganese dioxide, and other black mineral from the region of Magnesia in Greece, which also gave its name to magnesium and the iron ore magnetite. By the mid-18th century, attempts were made to isolate an impure sample of manganese metal. In 1774, an impure sample of manganese metal is obtained, which was done by reducing the dioxide with carbon. And this is the manganese. Manganese is a silvery gray metal that resembles iron. Manganese is hard and very brittle. Here are the physical properties of manganese: the density, melting point, boiling point, and also it's the picture of the solid manganese. So I'll move on to the atomic properties of manganese. Here are the atomic properties of manganese: atomic number 25, atomic mass, group, period, block, element category, electron configuration, electron per shell. And the picture shown is taken from periodic table. And here are the molecules of manganese. This is a molecule of manganese dioxide because pure manganese doesn't exist in the nature. It must be contained with another element, which is in this case is O2 or oxygen. Here are the mechanical properties of manganese: the tensile strength, yield strength, Poisson ratio, modulus of elasticity, shear modulus, hardness, brittle, Vickers, Rockwell A, Rockwell C. So let's move on to the next slide. Here are the chemical properties of manganese. It's difficult to fuse but easy to oxidize. And manganese metal and its common ions are paramagnetic, reactive to water, forming rust. It is non-flammable and part of the transition metals in atomic table. And here are the other properties including CIS number, thermal neutron cross-section, electrode potential, ionic radius, electronegativity, X-ray, and electrochemical equivalent. Here are the advantages of manganese. For hot-filled steel, it is capable to be in self-work hardens, increases the hardenability, increases the tensile strength, decrease the critical cooling rate, and it can act as a deoxidizing agent, and it can increase the impact strength of the composite or the steel. And here are the disadvantages of manganese: decreasing the brittleness. Then it's very hard to do the machining of manganese, which means it's very hard and very complex. Then the pure manganese is very hard to create, and then it tends to soften when being cooled rapidly, which is as a steel alloy steel contains high manganese, and then although its high hardness and high tensile strength, the material will not always be rigid. So yeah, that's a downside of the manganese. And here I am, the production of the manganese. Pure manganese used for production of iron-free alloy producing by leaching manganese or progressive extraction process involves directly reducing manganese ore in a heap leach. This is done by percolating natural gas through the bottom of the heap. The natural gas provides the heat and reducing agent, the reducing the manganese to manganese oxide from manganese dioxide. Then the iron reacts with the manganese oxide to form iron hydroxide, and elemental ele- elemental manganese is obtained, but it's only 92% of manganese. So we have to take it to the electrowinning facility to get it to 100% of pureness. So it's 100% pure of manganese. Here the simple of the production. And then thank you for paying attention. Um, I'm very sorry if there's a lot of mistakes from me, and then yeah, thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.